So, hello everybody. Today, right now, I'll be doing a simple demo for the continuous delivery part of this example voting application. So, we deployed this microservice application on a Kubernetes cluster. So, the whole job that was done was running those Kubernetes clusters, creating an Azure Kubernetes clusters firstly, and then what we did was we continuously delivered it using Argo CD. So our first approach was pretty simple. This is our Argo CD pipeline, and this is our basic repository. Uh, so basically, we have all the manifestations of Kubernetes already written for us. So how this basically happened was the we had three pipelines over here. This has three microservices. So for voting, for result, and for worker, we have different Docker files available. So we divide this into basically three stages. So let's say I run this particular pipeline. So when I run this particular pipeline and choose the main branch, let's say I run this. This usually happens in three stages. So the first stage is building stage. This is not the pushing stage. Building stage is basically it will build a Docker file. The push stage, what it does basically is it pushes the Docker file to the Azure container registry. So we have our container registry over here available. Just a minute. So we deployed all of it onto the Azure Kubernetes service. So this is our container registry, and we have our just a second repository. So we have three particular different repositories over each for a different microservice. Now what happens basically is we have a particular the pipeline. What happens is this pipeline creates a new tag every time it pushes the particular image to this Azure container registry. So a new tag gets generated. So right now we created one we ran a voting pipeline. So like if I go over here, so right now the time is 10:25. So yeah, basically at 25 a new tag is created. Now what happens after this is pretty simple. So now there was the two-step process over here. First the build happened, then the push happened. Then what happens is we update. So now here the Argo CD aspect kind of comes in the picture. So what basically happens is the Argo CD checks for any changes that comes into the Git repository, and whenever a changes comes into the Git repository, what happens is it will basically run this whole pipeline, run this whole process. So let's say now let me like just synchronize this. So you'll see there will be a refreshing state. So it will refresh over here because right now uh, basically what we're doing is we are updating a particular pipeline over, like we are updating a particular file over here. So inside the K8 specification we are updating the deployment file. So over here what we're doing is we are changing the image name over here. So image tag, we're adding the latest image tag over here. That is basically what we're doing. So nevertheless we are adding the latest image tag over. So how are we basically doing it? We're using this particular shell script to do it. This shell script is pretty simple and straightforward. In the shell script what we are doing is we are running this shell script on our Linux machine. So basically all the pipeline is happening on another AWS Linux machine where we have Azure pipelines installed onto it. So we are cloning it, and then we're just making a particular change over there where we are adding basically adding a new tag onto this particular file and then committing the change. So whenever the argo cd is like only checking for changes into this k8 specifications folder. So if he sees any sort of changes in this particular folder, it reruns the whole entire process. So that is basically what happens. Now there are particular aspects that comes onto over here. Now over here, the argo cd is supposed to um, push onto the repository, so like the container, so that the Kubernetes understands it. So that is done using these so-called personal access tokens. So we use these access tokens to do that. And another thing that also we do is we go to the settings over here, and we go to our repositories, and basically we connect to the repository. So we add our personal access token in the space of our the name, and also it gets connected the repository. So this is a very production, moreover like a industry level stuff application, because everything is private over here. And we are using our own server for running all of our pipelines also. So there are some aspects that I wanted to cover. So how did we set up the core Kubernetes cluster? That was pretty simple. Like we have something called AKS, the Kubernetes services. So we have our K88. So this is our first Kubernetes service over here. And we have I gave like a minimum of maximum of 2 and minimum of 1 a virtual machine that is supposed to spin up. So there are multiple pods in the virtual machine. So basically that is what happens. And then over here, like we can run this particular command over here in item. So let's say first of all, I can get my IP when I do this. So I have two particular IPs available because I have two virtual machines that are triggered using the Kubernetes service. And then let's say I want to check all of the um, services, like let's say I want to check all of the running pods. So I can just run this command, and then it will tell me like, okay, this is running, and this is running on a particular port. So basically normally these ports wouldn't be open, so we have to go to the Kubernetes fleet manager. So I think I have it over here. AKS agent. So you have to go to the AKS, the agents, and then what you have to do is you have to open some in our ports. So yeah, so over here firstly we have to open the port for the argo cd. So argo cd is basically on a different namespace. A namespace is basically a segregating factor for any Kubernetes cluster. So we have all of our argo cd stuff on one namespace. Excuse me. And then we have another of all of our IP addresses for our actual application on other of our port. So if you want to check out the voting application, it's basically running on the 3100 port. And then now I need to know. So let's say I can go on either one of these external IP addresses. Let me try these simultaneously. So if I go over here, and then if I go to, let's say, port 3000 31,000, so 3, so uh, I get this particular thing. And uh, if I go to the relative port for, let's say I go to 3101, this will open the result port. I just wanted to explain the architecture much more likely, so I didn't care about showing you the application. So let's say this gets a refresh. This is how it basically works. So if I open the same thing with for another VM, I can just open this, and then I can do it on the same port, so it will still work. Oh, wait a minute. This is 3000 and wait, which one was this? 31000. My bad. Just a minute. 31000, and then this opens the same particular application over here. So the particular application is using Kubernetes and running on both of the virtual machines, and the pods are running on both of the virtual machines and can be accessed from there. And some other thing is, yeah, the ports can be opened up using the fleet manager. And so other basic stuff is we are added Argo CD and other ASs, and we are push. So whenever there's a push on to, let's say I have any sort of changes that is done over here. So let's say in my vote app.py, let's say I don't want option A to be apple, I want it, let's say, to be, now currently this is apple versus banana, I don't want it apple versus banana, I want it sky versus land. So let's say someone commits it, so the whole process gets running. So after the thing gets run, a pipeline will get triggered, and the we have made changes onto the vote microservice. So basically the vote pipeline gets triggered. So when the vote pipeline is triggered, what basically happens is key, you can see all of the stages of builds, like so the build stage, push stage, and update stage. And also I have my machine running over here that is doing all of the jobs. This is an AWS machine. Let's say I close it off, it wouldn't run all of this, or wouldn't run normally. So the image is being pushed, and then uh, all of that stuff is happening over here, and then it will update, and then we can go to the Argo CD part, and then we can see the changes that is happening over here. So yeah, now it is running the shell script that that updates the the K8 manifests. And then yes, okay, now this whole thing is completed, and then I can just refresh this Argo CD thing. Okay, I think I have to sync it from here. And then when we sync it, it is refreshing here, from here. And on the if you go and just to get SVC, you will see over here key. Yep. Now this is running. If I like refresh it right now, this will show sky and land. So this is a whole pipeline that is created. So yeah, thank you for looking at the demo, and yeah, so yeah, bye.